we just finished single replacement reactions. Now we're going to go deeper with double replacement reactions. So double replacement reactions, Mr. Demetrius, again, what's the form of this? What's the
so it's yeah, I remember it's the wife swap, AX plus BY, and they just swap partners. And I come from a very small town, as you may know, and country dancing in the olden days was really, really bad. And they used to have an announcer to be like, do-si-do, and swing your partner, you tell you, and that would literally, you just switch partners. That's essentially what we're doing right here.
Now, the question we want to deal is we're eventually going to just give you the reactants, and you have to predict the products. And there's also instances where the reaction does or doesn't happen. So let's talk about when the reaction happens and doesn't happen. So in the reaction, the state of matter matters. And if you recall, there's this table in your notes. Take a look at the table that's right there, right? And what you need to have is you need to have the first two product or reactants, pardon me, must be aqueous. And then you have to make at least one solid. Generally, it's going to be plus another a solid plus an AQ. But if, for example, you get plus an AQ plus an AQ, this right here is no reaction.
And remind them again what aqueous is.
Aqueous means dissolved in water. So you take like the solid powder of AX, put it in water, and it dissolves because it needs what we call a medium for it to actually, it kind of separates the ions. Pre-AP students, you're going to learn more about why that is with something called ionic equations. But suffice it to say, the key is to make sure that you make at least one solid or the reaction doesn't take place. And both of these have to be aqueous. If one of these is a solid, it won't work. All right, so I think the best way to do this is do a few examples, Mr. Demetrius. Can you give us an example?
Yeah, let's try sodium sulfate plus
sodium sulfate.
Nitrate.
Let me watch what I'm going to do. If you do sodium sulfate, I'm going to actually, the first moment I'm going to do sodium sulfate, I'm going to say Na positive, SO4, -2. I'm going to write out the charges in what I like to call the scratch pad. And what was the other compound, Mr. Demetrius?
Plus calcium nitrate.
And Ca and NO3 -1. So I've got these right here. So I'm going to look up sodium sulfate. So when I put sodium sulfate together, that's going to be Na2SO4 plus calcium nitrate, CaNO3 2. Again, look at the charges that I'm making this. Now, the first thing I want to do is I want to check their state of matter. So first of all, let's check and see what their state of matter is. So sodium sulfate, if you look at the table, it is AQ. And actually, technically, we would write it AQ here. And then calcium nitrate is also AQ. Okay, so that's potentially, we've got to make at least one solid. And now we're going to trade partner, do-si-do, right? Now we're going to put the calcium with the sulfate. Oh, calcium is +2, by the way. And it's going to react with calcium sulfate, that's CaSO4. And then it's going to make sodium with nitrate plus NaNO3. Now, before I try and balance this, I think it's important that I check to see our table guy and see if one of these is a solid. And if you look at calcium sulfate, you'll discover that that's a solid. And sodium nitrate is an AQ. So this reaction actually happens. So then we're good. Now we have balance it. And let's take a look. Sodium, I got 2 sodiums here. I got 1 sodium here. So I'm gonna put 2 here. That gives me 2 nitrates. I already have 2 nitrates, 1 calcium. That was an easy, that's it. That's the answer right there. Just put a 2 in front of the sodium nitrate, but don't forget the S and the AQ. Simple, schmimple. So what would be another example, Mr. Demetrius?
Well, let's try this. Let's try lead 2 nitrate plus sodium phosphate.
All right, so now this is written in Word, which is a little tricky, isn't it, guys? And again, I think the scratch pad matters, okay? So let's make a little scratch pad right here. Lead is Pb, right? The Roman numeral +2. Nitrate, NO3 -1. Again, I'm polyion table if you don't have it memorized. Sodium is Na, periodic table, column 1. Its charge is +1. Phosphate is one of those polyions from the polyion table, is PO4 -3. So we want to build this, and then we want to figure out what the products are, because we don't know what the products are. We're going to have to like swap. So lead to nitrate. So Pb +2, NO3 -1. So that's Pb NO3 2 plus sodium phosphate, +1, -3. That's Na3PO4. Now, what we need to do, check out our other table, right? This table of AQs and S's, and it turns out that lead nitrate is AQ. That's good. And this is also AQ. So this reaction could happen. Now we want to trade partners. So now the lead is going to get together with the phosphate. Oh, that's a tricky one, isn't it? +2, -3. So that's going to be PB. I'm going fast, hoping you can, you know, sort of remember how to do this. PB3, PO4, 2, all right, because of the positive 2, negative 3, you got to get to a 6 charge. And that leaves us sodium nitrate, which is NaNO3. Now, Mr. Dimitrievich, can you look up lead phosphate and sodium nitrate on the table? What do we find?
Well, let's start with lead phosphate. And lead phosphate, if you take a look at it, it is a solid.
And sodium nitrate is AQ. So that reaction occurs. But of course, this reaction is a little tricky because we have all kinds of weird numbers. So again, start with the most complex one, which is the lead 2 phosphate with this 3 and this 2. So let's fix the lead, I guess. So if I've got 3 leads here, and over here I really have 1 lead, I can put a 3 here. Now I'm going to say I have 3 times 2 is 6 nitrates. I pop over here, I fix the 6 nitrates by putting a 6, but that screws up my sodium, 6 sodiums. I come over here, there's 3, I have to make this a 2. What does that do to my phosphates? 2 phosphates, 2 phosphates. Bingo.
Love how
it all works out. Notice how it's bouncing back and forth. That makes it a lot easier. And then, Mr. Dimitrievich, let's do one more example.
Yeah, let's try calcium acetate plus barium bromide.
So again, scratch pad. Calcium from the periodic table is +2. Acetate is C2H3O2 minus 1. By the way, to memorize that, you ever say this with me, everybody? Cho 232. Kind of like football. Cho 232. Carbon, hydrogen, oxygen. Cho 232 negative, right? There you go. So if you don't have memorized that. Barium is Ba, charges +2 from the periodic table, and bromide is just simply Br -1. So I'm gonna put them together, right? Calcium acetate, +2, -1. So that's Ca, C2H3O2, 2. So Cho 232 negative, but 2 of them because of that. And that's going to react with barium bromide. That's BaBr2. Now we look at this one and this one. What do we get? These are from the table right here, right?
Yeah, they're both aqueous. If you take a look.
Yeah, they're both aqueous. Good. And they're going to make what? We're going to put together barium acetate. So that's BaC2H3O2 plus, put calcium and bromide together, CaBr2. Now we need to look at the table again. And what do you see on the table there? Barium acetate is, go ahead.
Yeah, it's aqueous.
This one's aqueous. And then the calcium bromide is?
Also aqueous.
Oh, wait. So it's like calcium took acetate to the dance, barium took bromide to the ants, and they didn't actually trade partners. They were already happy where they were. So they kept the partners. So nothing happens. No one's going to be talking about this at the dance the next day because nobody's traded partners. You know, if they actually happened, right? Like in the previous examples, then you'd be talking about who got together with who, wouldn't you? So the answer to this one, actually, even if you do this, it's just no reaction. All right. So folks, you're going to do lots of examples in class, but that's how you do double replacement reactions. We'll see you in class.
See you next time.